Hello viewers, welcome back. I hope you are doing good. Today we are going to solve another question from line 75 series. This is Leetcode question number 11, container with most water. Here we have been given an height array which gives the values of the height of the vertical lines I'm talking about. And now we have to find the most area or most water can be contained by a container. So we need to understand how we have to create container here. We have to use these vertical lines and then create a container. If we take any two vertical lines out of this height array, then that makes a container. So any pair of two lines is a container, and we need to see which pair gives me most area. So area is calculated by using the width and the height. So if we take any two containers, the height will be the minimum height of the container, sorry, minimum height of the vertical lines. Because in this example, we can see these are the heights given, and these basically represent the vertical lines. Now for to calculate a particular area of a container, I am going to take these two vertical lines, and this will make a container, right? How much water I can store? I can store water till here, right? So the vertical line which is having the lesser height between the pair, that will decide the height of the container, right? So I can't put more water beyond this, the minimum height. This is going to be my area. And now we need to maximize it. So for seeing how we can maximize it, we need to literally we need to calculate the area of each of the container, and then we can say, okay, what maximum area we can get, right? And also few things to consider from this question. For calculating area, we need width, and width we can get by subtracting the indexes of this array, because the x-axis represents the indexes. So let's say I am here, this might be 0 index, this will be 1 index, this is 2 index, this is third index, right? So now what is the width between these two? 3 minus 2. So we can easily get the width by subtracting the indexes from the height array. And what will be the height? Height will be the minimum of the pairs what we have created. So I think the area calculation is clear to you. So what would be my brute force approach? The brute force approach is going to be very simple. I will fix a vertical line and will make pair with every other vertical line. After making a pair, we are basically creating a container, and then we'll be getting some area, and I will see which is the best area, and that will be my max area. So I am going to take a max area variable initially having value 0. Now I have made a pair, I got some value, I will just update it here with the new value. Now since I got one pair answer, I will discard this and I will move to the next. So now I'll make the pair with this vertical line, the third vertical line, and my area looks like this. Next time I'm going to take next vertical line, and my area is going to look this. Next time I'm going to take this vertical line, and area will look like this. So I'll keep on doing this till we reach at the end. Whenever I'm getting the better area than the previous one, I mean the more area than the previous one, I'll be updating my max area. So now I have done taking pair of this vertical line with every other vertical line. Now I'll do the same for the second vertical line in the second iteration. In the third iteration, I will do making pair of third vertical lines with every rest of the vertical lines. So what is the time complexity of this approach? For every vertical line, we are doing n comparisons because there are n other numbers, n minus 1, but we will just consider it more or less as n, right? So for every line, we are doing n comparisons because we are making n pairs, right? So that means and how many numbers or how many vertical lines we have n vertical lines. So for one we are doing n comparison. So for n, how many comparisons we are going to do? N into n. That means time complexity is O of n square. So that is not good. So how we can do better than this, because interviewer might not be happy with this. So thing to consider from this solution is, for getting the maximum area we need two things: better width and better height, right? Both should be more. So for ensuring I can get maximum width, I can start from the extreme. If I put my left pointer here and right pointer at the extreme right, so I'm ensuring I'm getting the maximum width. So my area will be maximum. Now the second limiting factor is height. I need to ensure that height should be more, right? So now out of these two vertical lines, the red one, the last red and the first black, which is the minimum height? The minimum height is the left one. So I will calculate the area now. I will update my max area variable, but in search of better area, I will move forward from left to next position, because the limiting factor for me in the previous case was this, the first vertical line. So I have to move forward and see for the better height. And if it would have been opposite case, if my minimum height or the lesser height would have been the right one, I could have moved away from that position to get the next better height. So we have to just use this algorithm that start from the extreme to ensure the maximum width, and then whenever we are getting minimum height, try to see the next value. So let's dry run our example and see how it works. Initially, my left is at the left extreme and right is at the right extreme. I have written the indexes. Left is at the 0th index, right is at the 8th index. Maximum area is 0. Now to calculate the area, we need width. Width can be taken by subtracting the index values. So this is I minus 0 into the minimum height. So minimum of 1 comma 7. So that comes out to be 8 into 1. That is 8. So I will update it with 8. Now next time, what was the minimum height in the previous pair? The previous pair, the minimum height was this. So I will move my left to the second value. So now what is my width? Width would be again 8 minus 1, because now I am at 1. And what is the minimum area? Sorry, the minimum height. So height now would be 8 comma 7. So this is 7 and this is again 7, which is like 49. So I will update this with 49. Now what was the minimum height between the previous value? So minimum height was 7. So I will move my R here now. So R will move here, and now to calculate the area again, we need to see the width. The width would be 7 minus 1 and height would be minimum of 3 and 8. So this is 6 into 3, that is 18. So I am not going to update because this is not a better answer. Next time, what I'm going to do, what was my minimum height? Minimum height was 3, so I will move it here. So now my right pointer has come here. So if I subtract the indexes 6 minus 1 into minimum of these two, minimum of these two. So here we can see that both values are 8. So I can take any of those. This is going to be 8 and this is going to be 5, right? So this is, I am getting 40, which is not better than the previous value. So I'll not take this value. Now the thing is, this is a very interesting thing, that both the values are equal. Where should we move next? Either we move left or either we move, or I move right. So in this example, we can move anything. We can move either left or we can move either right. That is up to us. That is totally perfectly fine. So I'm going to move this left one. So I will come here. So I'm going to move my left to this position and R will be here only. Now if I subtract the indexes, this is going to be 6 minus 2 into minimum of 8, 6. So this is 8 and this is 4. This is 8. So answer is 32, which is again less. Next time I will move, now I'll move my left again. So this will be 6 minus 3 and the height will be minimum of 8 and 2, which will be 2. So this is again less value. We are not going to take this. I think in the previous iteration we have taken the max height, but we should have been taking the minimum height only. Now we will be moving here, and if I take the difference of the indexes, this is going to be 6 minus 4. And what is the minimum height between 5 and 8? 5. So this is 2, this is 5, this is 10. Now I will move here to 4, and what is the value here? 6 minus 5 into minimum height is 4. So this is going to be 4. So neither I was taking that, neither nor I am taking this. So basically I have not updated, and now I will be moving my left pointer to this position, at the same position where my right pointer is. So my left and right both are at this position. So now I will stop my iteration, and the best answer I got is 49. So I hope that you have understood this, and now we can go ahead and code this up. So we need to have two values. Left will be 0 at 0, and right would be at the extreme index. Now we'll take a loop. We'll take a while loop, and we will be doing our comparison till we reach left is not crossing right. Even both can't be equal, because for creating a container, both the height should be different. If left and right are same, they can't create a container. If one vertical line can't create a container, so that is why we can't take equal to. They should not cross, and even they can't be same. Now for calculating the area, we will take a max area variable as well for keeping the maximum value. Initially the value would be 0. And now for calculating the area, I'll be taking a variable called current area is equal to, that would be width. So what is going to be my width? Width is going to be right minus left, because those are the indexes, right? And that should be multiplied by the height, and height would be the minimum of the two heights. So height of left comma height of right. Okay, looks fine. Now we need to see if I can get a best maximum area. So what we can do, we can take math.max to compare the previous max area and the current area. Now if my current area is more, then this max area will be getting updated here. And also after doing this, in search of better height, I need to see which was my limiting height. So we'll just check that height of left. If that was less than the height of right, then that means left should move forward. But if that was not the case, then I can just move forward right. So I'm not taking the equal to case. That equal to case will go into the right, this else part, and we will be updating right plus plus. So we could have taken equal to here, and we could have done left plus plus in that case as well. Doesn't matter. In equal to case, we can increment either left or right. So now we are making sure that we will be looking for the better height in case of limiting height. And we have ensured that we are getting maximum width because we have started from the extremes. At the end, we can just return the max area being calculated. So we will just return this variable. But I think before moving forward, we have made a mistake. Just correct it. This should be right minus minus, because we are already at the extreme and we should be going inwards, right? From right to left. So this should be right minus minus. Now let's run it. And this is passing for the two cases. Let's submit it to see if this works for all the other cases, and we are getting good runtime as well. I hope that you have understood the solution and you can try yourself. This solution is not that difficult, but to arrive at this, we needed the brute force approach to draw some conclusion from, and then we got it. So the solution is simple, but we need to get to this, right? This is basically known as two-pointer approach because we are taking left pointer and the right pointer. I hope that you have understood the solution well and like the video. Please hit the like button and subscribe to my channel. Keep watching. We'll see you in the next video.